Have you ever stopped to wonder how your computer, say in London, can talk perfectly to a server all the way over in Tokyo? It's not magic, not really. It's all thanks to this kind of secret rule book for the internet called the OSI model. So let's dive in and figure out how this whole thing actually works.
So, picture this. You click send on an email. What actually happens next? I mean, really think about it. You type something up, you hit that button, and bam! Moments later, it pops up on a screen maybe thousands of miles away. It totally feels like magic, right? But it's actually this incredibly well-organized journey. And guess what? We're going to follow that journey step by step right now.
You know, back in the early days of computing, it was just chaos, a total mess. Imagine you're trying to send a letter in English to someone who only speaks Japanese, and the post office you're using only accepts square envelopes. It's just not going to work, right? Well, that was kind of like the early internet, a digital Tower of Babel where all these different computer systems from different companies, they just couldn't talk to each other at all.
So, to fix this chaos, this brilliant group called the International Organization for Standardization, or ISO for short, came up with a really elegant solution: the OSI model. Now, and this is key, this isn't a physical thing. It's not a piece of hardware or a program you can download. It's better to think of it as a blueprint, a conceptual framework, a universal translator that finally lets all these different systems speak the same language.
And this is it, the famous 7 layers. The model takes this super complex process of sending data across a network and breaks it down into 7 nice, manageable layers. Our email? Well, it's about to go on a trip. Starting at the top, going all the way down this stack, getting packaged up at each level, before making the journey back up on the other side. Okay, I know what you might be thinking. 7 layers? How am I ever going to remember all of those? Well, don't worry, because network engineers have been using this awesome mnemonic for decades. You just have to remember this phrase, starting from the bottom, from layer 1. Please do not throw sausage pizza away. See? Physical, data link, network, transport, session, presentation, and application. Pretty clever, right? All right, let's start the journey. So when you send that email, your data actually starts at the very top, at layer 7, and it makes its way down through every single layer. The best way to think about it is like you're preparing a package to ship. Each layer adds its own special wrapper, its own set of instructions, before handing it off to the layer below.
Okay, our journey kicks off right at the top, layer 7, the application layer. Now, this is the one you actually see and touch. It's the only layer you directly interact with. We're talking about your web browser, your email program, whatever software you're using to create the data in the first place. So, going back to our letter analogy, this is you actually writing the content of the letter.
Next up, your data drops down to layer 6, the presentation layer. Think of this layer as the universal translator and security guard, all in one. Its main job is to make sure your data is in a format that the other computer can actually understand. But it also handles really important stuff like encryption. You know, when you see that little padlock in your browser or the S in HTTPS, that's layer 6 at work, using things like SSL and TLS to scramble your data into a secret code. Oh, and it also compresses the data to make the file smaller, which means it'll send way faster.
All right, from there we're down to layer 5, the session layer. This layer is basically the conversation manager. Its whole job is to open up a communication channel, make sure that connection stays open and stable while you're talking, and then close it down neatly when you're done. The analogy here is perfect. It's like calling your friend to make sure they're actually home before you drive over with that package.
Now we get to a really crucial step, layer 4, the transport layer. I like to think of this as the logistics manager for your data. First, it takes your big message and chops it up into smaller pieces called segments. Then it has to make a huge decision. How are we going to send this? Do we need it to be super reliable with guaranteed delivery? Or is speed the name of the game? And this choice comes down to 2 big players, TCP and UDP.
And believe me, this choice is everything. First, you've got TCP. Think of TCP as certified mail. It's all about reliability. It does this thing called a 3-way handshake to make sure the connection is solid. It numbers every single piece of your data, and it checks to make sure every single one arrives in the right order. This is what you use for email or loading a website, where you absolutely cannot lose a single bit of information. Then you have UDP. UDP is like a postcard. It's all about speed. It just throws the data out there and hopes for the best. No checking, no guarantees. Why would you want that? Well, for things like video streaming or online gaming, where a dropped pixel or a tiny blip in the audio is no big deal, but a laggy connection is a disaster.
Okay, we're getting deeper into the stack.
Welcome to Layer 3, the network layer. This is literally the global postal service of the internet. It takes those little segments of data from the layer above, bundles them into something called a packet, and then slaps an address on it. But this isn't just any address, it's the IP address. That's the unique global address for the destination. Then the routers, the workhorses of this layer, act like postal sorting centers, figuring out the absolute best, most efficient path for your packet to take across the entire internet.
So the journey is getting super local now. At Layer 2, the data link layer, we're no longer talking about crossing the globe. We're talking about getting from your computer to your Wi-Fi router. If the IP address is like the city and street address, the MAC address is like your specific apartment number. It's a unique hardware address that's burned right into your device. This layer manages that direct point-to-point connection and does one last error check before the data takes its final leap.
And finally, we've hit rock bottom. Layer 1, the physical layer. This is where all that digital data, all those ones and zeros, become a real physical thing. We're talking about turning your email into electrical pulses zipping down a copper cable, or flashes of light blinking through a fiber optic line, or even radio waves beaming out from your Wi-Fi antenna. This is the actual truck, the plane, the roads, the physical stuff that carries your message.
Whew. Okay, so our email has been chopped up, packaged, addressed, and sent out into the world. But guess what? The journey is only halfway done. Once those physical signals hit the destination computer, the entire process happens again, but this time in reverse. It's time to unwrap the present layer by layer.
And this process is just beautiful. It's a perfect reversal. So Layer 1 on the other side grabs those physical signals and turns them back into ones and zeros. Layer 2 checks the MAC address and says, yep, this is for me, and checks for errors. Then Layer 3 looks at the IP address to confirm the final destination. After that, Layer 4 gets to work grabbing all the packets, and if it's TCP, carefully reassembling them in the right order. Layer 5 opens that session back up saying, hello, I'm ready to talk. Layer 6 decrypts everything, decompresses it, and gets it ready to be displayed. And finally, all the way back up at Layer 7, boom, your original email appears on the screen, perfectly put back together.
Okay, so you might be thinking, this model sounds kinda old. It's from the 70s. Is this thing still even relevant today? And the answer is a huge, resounding yes. In fact, you could argue it's more important now than it's ever been.
I mean, this quote really says it all. The OSI model is the bedrock, the absolute foundation of internet communications. Now, it's true that in the real world, engineers often use a slightly simpler model day to day, but the OSI model, that's the ultimate blueprint. It's the reference guide that everyone comes back to.
So why does this all matter to you? Well, for one, it's the ultimate troubleshooting guide. If your internet's not working, is it a Layer 1 problem, like a cable that's unplugged? Or is it a Layer 3 problem with your IP address? This model gives you a logical way to figure it out. It also gives all the tech pros out there a shared language to talk about this stuff. And honestly, it helps all of us appreciate just how all these incredibly complex pieces work together so perfectly to create the internet we use every day.
And that brings us to one last fun thought. The 7 layers we talked about, they perfectly describe the technical side of the network. But in today's world of AI, the cloud, and, as humans, a lot of IT folks joke about a Layer 8, the user, or sometimes the political layer. But seriously, as technology just keeps exploding, what do you think a real new Layer 8 would even be? What would it be responsible for? Just something to chew on. Thanks for joining me on